Hi class, so in this video I'm going to review with you the review sheet for the periodic table quiz that is going to be on Monday. Firstly, you can see that there's a bunch of vocabulary here, and you should go to Quizlet, quizlet.com, where you can download the app on your smartphone. If you type in my name, Maheshalur, into Quizlet, there's a little search bar at the top, and you click the most recent tab. You will see a vocabulary list that is called chemistry periodic table, and these are the words that are going to be in there, and you can use the games in there to study, so you should definitely do that. Okay, so the first question: what are the properties of nonmetals, metals, and metalloids? So metals are shiny and malleable. They react with HCl and CuCl2, and they conduct electricity. Nonmetals are dull, they're brittle, they do not react with HCl and CuCl2, and they do not conduct. Now with metalloids, it's going to be some combination of both. Some combination of metal and non-metal properties. In the next question, it says, where are each located on the periodic table? So if you draw a periodic table, and you have the stair step, the metals are located here, to the left of the stairs. The non-metals are located here, and the metalloids are located on the stairs. Number 3, who is considered the father of the modern periodic table? And that is Mendeleev. How did he organize the elements to receive his version of the periodic table? He organized them based on chemical and physical properties of elements. Number 5, what allowed him to predict the existence of unknown elements? After he arranged them, he realized that there were gaps in his periodic table. When he organized them according to the chemical and physical properties that they had. Based on the properties of the element around the missing element, he was able to figure out its properties, which leads us to this question on how he did it. What is the ionization energy for the element with atomic number 13? So you look at this graph, and you notice that 13 here is missing. So what you do is, you notice the pattern that is developing here. You notice that even if you just drew a straight line across here, any number around here would be just fine. So you draw that across, and that's maybe around 700. And there should be units, except that this activity didn't give us the units of the ionization energy, so it doesn't matter. But in general, you would write the units here. In this question, you had to complete, in this activity, you had to complete this chart. So you can see that you only had to complete 3 boxes. So the way you do this is you subtract the initial from the final volume. So you would show your work, 16.0 milliliters minus 14.8 milliliters. Remember to show your work on another sheet of paper. And then the third one, 18.5 milliliters. Then I write that in, 1.2 milliliters. And there you go. In the next part of the question, it says complete the table below. So how you determine the average density of tin is you add these 3 values together and divide them by 3. So I'll do that up here. Remember to do it on your own sheet of paper. Then you take all those 3 and divide by 3, and you get the answer 7.2 grams per centimeter cubed, but you need a plus or minus value. So the way you do that is, you see from 7.2 to 7.4, it's an increase of 0.2, so that's a plus 0.2. From 7.2 to 7.0, it's a subtraction of 0.2, so you know that it's plus or minus 0.2 is the uncertainty value for this average. In cases where the subtraction and the addition is different, you always pick the higher number. So on this last row, you have to determine the densities, and the way you do that is use the table above, use the information from above to answer this question. So you take 1.2, which is the volume of the solid, and you divide it by you divide it into the mass of the solid. So 12.85 divided by 1.2, 15.61 divided by 1.4, and 15.28 divided by 1.4. So I've shown you the work and shown you how I did the calculations, and now you plug these numbers into the chart. And there you go. And if you were to do the average of these three, you'd notice the average would come out to this number. On this question it says, graph your density versus period number and predict the density of germanium. So, as you did in the lab, you will graph density on the y-axis. You write the units, grams per centimeter cubed, and you write period number on the bottom here. So you notice, if you look at periodic table, silicon is in period 3, tin is in period 5, and lead is in period 6. So this is what you graph down here. 3, and you skip 1 for 4 because that's where germanium is, 5 and 6. Make sure the gaps in between are always the same amount. So I did 2 boxes for every period. And you notice that the densities that you're graphing here, the average ones, the highest number is 10.9. So I'm going to make sure that I am able to graph everything within this piece of graph paper. So I'm going to put these numbers in for these 3. And once you do that, you should draw a line which fits through these points. And it doesn't have to be a perfect line, it just has to be a line that is the average of the points, and it looks like that. And then what you do is you figure out, okay, I want to know the density of germanium, and if you look on your periodic table, germanium is in period 4. So you follow that up to about here. It's an intersection, and you follow it across, and it looks like it's 5.0 grams per centimeter cubed. Then it says calculate the percentage of the actual density of germanium. If the actual density of germanium is 5.32 grams per centimeter cubed, then it has the equation here. Sorry for it being so blurry. And then you put your number in, so PE equals, that's my measured value, and notice this is an absolute value sign over it, so it's 0.32 divided by 5.32, and you do have to multiply by 100%, and when you do that, you get 6.02%. And that's how you do all the questions on the review sheet. If you can do this, you're going to do really well on the quiz. Please ask if you have any questions. Have a good weekend. Bye.